Understanding distance time and velocity time graphs is essential for anyone studying motion, whether in physics or everyday life. These graphs provide a visual representation of how an object moves over time, allowing us to analyze its behavior, speed, and changes in direction. Let's break down the significance of these graphs and how to interpret them effectively. First, let's focus on the distance time graph. This graph plots distance on the vertical axis and time on the horizontal axis. When we draw a distance time graph, we are essentially mapping how far an object has traveled over a specific period. For example, if you were to plot the journey of a car traveling from one city to another, each point on the graph represents the total distance the car has covered at a given time. When the line on the graph is straight and sloped upwards, it indicates that the car is moving at a constant speed. The steeper the slope, the faster the car is traveling. Conversely, if the line is horizontal, it means the car is stationary, and if the line slopes downwards, it indicates that the car is returning to its starting point. This ability to visualize movement is invaluable. It allows us to not only see how far the car has traveled, but also to infer its speed at different intervals. Now, let's consider how we can show journeys on a velocity time graph. In this case, the vertical axis represents velocity, while the horizontal axis represents time. The beauty of a velocity time graph lies in its ability to convey changes in speed and direction. For instance, if the velocity is constant, the graph will show a horizontal line. If the object accelerates, the line will slope upwards, indicating an increase in speed. If it decelerates, the line slopes downwards. What's particularly interesting about velocity time graphs is that they can also help us understand the concept of acceleration. If the line is straight and sloping, the object is experiencing uniform acceleration. If the line curves, it indicates that the acceleration is changing. This allows us to analyze not just how fast an object is moving, but how that speed is changing over time. By interpreting these graphs, we can gather a wealth of information about an object's journey. For example, if we have a distance time graph that shows a car moving steadily for a while, then stopping, and then moving again, we can deduce that the car traveled a certain distance, paused, and then resumed its journey. The same can be analyzed using a velocity time graph, where we would see a horizontal line followed by a drop to zero, and then a rise again. To effectively draw these graphs, one must pay attention to the scale used on both axes. Proper scaling is crucial, otherwise the graph may misrepresent the data. For instance, time. If the time intervals are too large while the distance intervals are too small, the graph will not accurately reflect the object's journey. It is also important to label the axes clearly and provide a title for the graph to ensure that anyone reviewing it understands what is being represented. In conclusion, mastering distance time and velocity time graphs is not just about being able to draw them. It's about understanding the story they tell. They provide a framework for analyzing motion that is both intuitive and powerful. Whether it's for academic purposes or real-life applications, these graphs offer insights into the dynamics of movement, helping us to visualize and interpret the world around us. By practicing how to draw and interpret these graphs, we enhance our ability to engage with the principles of motion, making us better equipped to tackle problems in physics and beyond.